Hello and welcome back to Diksha Karnataka YouTube channel and all the COMEDK aspirants. Today I am going to bring you top 50 most expected questions from all across the library that we have. So very important top 50 questions that we are going to discuss today, and I am going to discuss them quickly so that you don't waste too much time watching this video. You also have to prepare for your COMEDK preparation, so don't wait, waste too much of amount of your time. So let's start with today's session. So here is the first question. A, B and C are the parallel sided transparent media of refractive index N1, N2 and N3 respectively. They are arranged as shown in the figure. A ray is incident at an angle theta on the surface of separation of A and B, which is shown in the figure. Okay, after the refraction into medium B, the ray grazes the surface of separation of the medium B and C. Then sine theta equals to. Very interesting question. So let's solve this. So first let us understand what is happening. Here we have three mediums, N1, N2 and N3. Light started from point in the medium A. It incident at an angle theta to the medium B, and after refraction it moves into medium B, and then from medium B to C, what happens? It grazes the medium. That means at this juncture the angle of incidence is basically the critical angle, right? So only if the angle of incidence is critical angle at this point, then only it will grazes the surface, right? So we can say that this angle is theta C, right? This angle is theta C, and if you see that this angle, this line and this line, they are parallel lines and they are in the same medium, right? So this line and this line, they are parallel, both are perpendicular, right? These lines are parallel, so that means if they are perpendicular to two parallel lines, the angles must be lines must be parallel. So this and this angle are alternate angle. So if we say this angle as theta C, then definitely we can say this angle is also theta C. Right now, what we will do, we will apply the first we will apply the condition for total internal reflection, that is sine theta C is basically the refractive index N3 and N2 by N3. Right, this is the condition for total internal reflection. So sine theta C is basically N2 by N3. But this is not over yet. What we have to do, we have to apply Snell's law for these first two mediums, that is N1 sine theta equals to N2 sine theta C. Now you will ask, sir, why you have written it like this? Because there is a small mistake over here. It will be N incident will be below and N3 will be the outer medium. Okay, so this is the formula. Now why I am writing it like this? Because this theta C is for this angle. Okay, sine N1 sine theta I is equal to N2 sine theta R, right? Instead of R, I am writing theta C because we have found from geometry these two angles are equal. So if this angle is theta C, this angle will also be theta C. Also for these two mediums, this angle is also angle of refraction as well. So from that we are writing the Snell's law. So N1 sine theta equals to N2 into N3 by N2. Now N2 cancels, so from there we get sine theta equals to N3 by N1. So correct answer is N3 by N1. Option B is correct. Now next question. Maximum acceleration of the train in which a 50 kg box lying on its floor will remain stationary given the coefficient of static friction between the box and the train's floor is 0.3 and g is 10 meter per second. So we have a train, okay, so this is a train and this is a goods compartment where we have kept one box of mass 50 kg. So this is a 50 kg box. Okay, now let us first calculate what is the weight of the box. Weight of the box will be 50 into 10 mg, right? So normal force will be the same value. So what is the force on the box? Force on the box, that is the frictional force, will be force of friction will be mu mg, that is mu into 50 into 10, and mu value is given here 0.3. So 0.3 into 500, 0.3 into 500, that is 150 Newton, right? So it will be 150 Newton. This is the force of friction acting on the block, right? Now they ask it, what is the maximum acceleration? Maximum acceleration, suppose, is A. Okay, so if the maximum acceleration is A, and what is the force acting on this mass because of this acceleration? The force acting on this mass is given by, from Newton's second law, force is ma, so F is equal to ma. Now in the equilibrium condition, this force and this force both has to be equal. So from here we can say ma should be equals to 150. That is, A should be equals to 150 divided by 50. Why? Because mass of the block is 50 kg still. So you have to divide it, you will get 3 meter per second square. So the maximum acceleration will be 3 meter per second square. That is, option B is correct for this question. Now next question. The temperature at which the speed of sound in oxygen is the same as that of in hydrogen at 27 degrees Celsius. So we know that for speed of sound is given by gamma RT by M. Speed of sound is given by gamma RT by M. Now here we are talking about oxygen and hydrogen. Now oxygen and hydrogen both are diatomic gas. So for diatomic gas, gamma value is constant, right? 1.4. So gamma is not a concern. Only thing is that hydrogen temperature is given 27 degrees Celsius. We need to find the temperature of oxygen. Okay, so it says that V of O2 must be equals to that of hydrogen, right? Now we are trying to find temperature of O2, and mass of O2 is also our concern, right? So mass of O2 is also different than that of the hydrogen. So now gamma is same, that's why we are not writing it. So TH2 divided by mass of hydrogen. Okay, H2. Now let's put these values. The square root will go up, go out, gamma cancel, R cancels. So TO2 by mass of oxygen. Mass of oxygen molecule is 32 equals to TH2 is 27 degrees Celsius. 27 degrees Celsius means 300 Kelvin divided by mass of hydrogen. Mass of hydrogen molecule is 2. So TO2 must be equals to 150 into 32. Okay, 150 into 32, which will be approximately 450, 4,500 in plus 300, that is 4,800, and this is in Kelvin. So in degree Celsius, what will be the value? So degree Celsius, the value will be T small TO2 will be 4,800 minus 273, that is 4527 degrees Celsius. Okay, so 4527 degrees Celsius. Correct answer is option A. Now next question. The wire loop shown has a clockwise electron current. What is the direction of the magnetic field at the point P? So now here we have a clockwise electron current. So electron is rotating in this direction. So if electron is rotating in this direction, magnetic field is generally defined by a positive charge, moving positive charge, right? So the right hand rule that we apply is basically applicable for positive charge. So if electron is orbiting in this direction, we can say the conversely there is a conventional current which is going in the anti-clockwise direction. So if the conventional current is going in the anti-clockwise direction, then you have to point your fingers towards the current and your thumb will point the direction of magnetic field, which is out of the page. So correct answer is out of the page, option D. So very careful, electron is moving in this direction, but current will be in the opposite to that of the motion of the electron. So current will be out of the page. Next question. a 12 kg bomb at rest explodes into two pieces of 4 kg and 8 kg. If the momentum of 4 kg piece is 20 Newton second, the kinetic energy of the 8 kg piece. So first of all, you have to realize that there was only one single bomb. Okay, you can do it in a longer way, or you can do a little bit smarter way. So because it is a single bomb which was initially at rest, so after they separated, their momentum must be equal. From the conservation of momentum, the momentum of individual masses must be equal. So momentum of the 4 kg mass is already given 20 Newton per second, and they ask you what is the energy, kinetic energy of 8 kg piece. So you can find the speed from there, and then you can find half mv square, or there is a shortcut way, because we know that 8 kg piece will also have the same amount of momentum. Because of the conservation of momentum, direction will be opposite, but the value of the momentum will be the same. So kinetic energy can be given by Ek is given by P square by 2m. This is the shortcut formula to calculate kinetic energy when momentum is known. So P square means 20 square divided by 2 into 8. That is 400 divided by 2 into 8. So it will be 450 25. So kinetic energy will be 25 joules. That is option A. Next question. A lamp and an ammeter are connected to a source as shown. What is the electrical energy expended in the lamp in 0.3 second? So here we have a lamp. Okay, current passing through the lamp is 5 ampere. The voltage is 10 volt. Now what is the energy expended? So that is basically, here we will use the formula vitamin. Okay, energy is vitamin. Okay, vitamin is V is given by 10 volt, current is 5, time is 3 seconds. So it will be 150 joules. 150 joules. Yes, 150 joules is the answer, not watt. Watt is the unit of power, so be careful, it will be 150 joules, not watt. Okay, if it is only V into I, then it is power, but when it is vitamin in the full form, that is energy, that is joules. The magnifying power of an astronomical telescope having an eyepiece of focal length 0.05 meter is 9 when viewing at a distant object. The length of the telescope is. So magnification is given. Magnification given means the magnification is given and the focal length of eyepiece is also given. So what is the magnification? Magnification is FO by FE, and that is equals to 9. So what is the focal length of objective? Focal length of objective is 9 into 0.05, that is 0.45. This is the objective focal length. So what is the length of an astronomical telescope? Length of an astronomical telescope is very, very important. That is FO plus FE. That is 0.45 plus 0.05, that is 0.5 meter. Okay, so it will be 0.5 meter. Option A is correct. Next question. Light enters at an angle of incidence in a transparent rod of refractive index of the material of the rod of the light. Once entered into it, it will not leave it through its lateral phase whatsoever with the value of the angle of incidence. So here we have a optical fiber kind of structure. Okay, optical fiber, cylindrical shape, right? Now a light enters into it at some angle of incidence. Okay, so what is the angle of incidence? Suppose the angle of incidence is I. Okay, now whatever is the angle of incidence, the light will never have this condition. This is the condition where it is through its lateral phase. So if the angle is if the angle of incidence in this between inside the surface is more than this angle, then it will always come back, right? But if it is less than this angle, it might escape to the second medium. So you have to have a material of refractive index such that it will never, the maximum angle it can have is this angle. This is the maximum value of the angle. So basically this is the critical angle between the medium and the air. Okay, outside medium is air and this refractive index is n. Okay, so angle of incidence is given by I. Okay, and if the angle of refraction in this medium is r, then we see that this is a normal, this is also a normal. So these two normals, once they dissect each other, they give you an angle of 90 degree over here. That is the main point of this question. So this angle is 90 degree. This is a right angle triangle. So this is a right angle triangle, means r plus theta c must be also equals to 90 degree. So r plus theta c equals to 90 degrees, or r equals to 90 minus theta c. Now we will apply Lenz's law, that is sin I equals to n sin r, right? Or n sin 90 minus theta c, or n cos theta c. Okay, now what we will consider here, what is the maximum possible angle of incidence. Okay, if you increase the angle of incidence, theta c value will also increase, both are directly proportional. So what is the maximum possible angle of incidence? So maximum possible angle of incidence is when the light is falling normally, falling 90 degree at an angle 90 degree with the normal. Okay, so in that case, what is the value of sin theta? Sin theta will be 1. So maximum possible value is this. This is the limiting case. Any angle less than that we can manage, right? So if this condition is valid for sin I is equal to 1, then it will be valid for all the other angles, right? So we have to find this condition for the maximum possible angle of incidence, that is sin I is equals to 1. So cos theta c, from here we get cos theta c equals to 1 by n, or squaring both sides we get cos square theta c equals to 1 by n square. Now what is cos square theta c? So cos square theta c is basically cos square theta c is 1 minus sin square theta c, right, equals to 1 by n square. Now what is sin theta c? Sin theta c is 1 by n, sin theta c is 1 by n, that is the condition for total internal reflection. So we'll put that over here, 1 minus sin square theta c, so it will be 1 by n square equals to 1 by n square. So here we have 1 equals to 1 by n square plus 1 by n square, that is 2 by n square, or n square equals to 2. Cross multiplication, right? From here we get n must be equals to root 2. This is the minimum possible value of refractive index. Any angle more than that, definitely good. So we see that this is the correct answer. N must be greater than that of root 2, greater than equals to, you can say, because the condition is it should not exit, right? So it is not exiting here, it is just grazing the surface. So condition should be n greater than equals to 2. Now next question. If V1 and V2 are the velocities of sound in air at 8 atmospheric pressure and 1 atmospheric pressure, the ratio of the velocities will be. Now very interesting question. You might think that velocity of sound is given by square root of gamma p by rho. Now this is not actual correct relation. From here you have to convert it into the fact that it is gamma RT by m. Here the quantities are constant. In this case quantities are not constant, because P and gamma both can P and rho sorry, I made a small mistake. I wrote gamma on both sides. It is gamma P by rho. Rho is the density, right? If you change the pressure, density will also change. For example, if you increase the pressure, density of the gas will also increase. If you decrease the pressure, density of the pressure will also decrease, because the gas is now more separated than previously, right? So this is a false equation, even though you might think that V is proportional to P, but you have to convert it into RT by M, because mass for a given space of air is constant. Okay, so if you have a container containing air, okay, maybe you increase the pressure, maybe you decrease the pressure, but as long as the entire gas is inside, okay, the mass is constant. So mass is constant, R is constant. So from here we see that velocity of sound is directly proportional to root over of temperature. It does not depend on pressure. So as long as temperature is constant, it will not change based on the pressure. So the ratio should remain constant, that is 1:1. So this is a full question, intelligent question, but full question. Okay, if you know it, you can answer. If you don't know it, you will not be able to answer. An equiconvex lens of focal length 10 cm in air is immersed in a liquid. Then its focal length changes to -10 cm. If the refractive index of the material of the lens is 1.5, the refractive index of the liquid is. So let's see, we know that 1 by F equals to n minus 1 by 1 by R1 minus 1 by R2. Okay, so this is the initial condition. Say this is F1. Okay, now when you immerse it into the liquid 1 by F2, the focal length of the lens will be, this is focal length of the material of the lens or glass, whatever it is, and once you immerse it in a liquid of refractive index N2, then its effective refractive index becomes N1 by N2, okay, minus 1, and the other part remains same, 1 by R1 minus 1 by R2. Now just divide them, you will get F2 by F1, because you are dividing this by this, so this was double division, so it will go up, right? I hope you are clear. It will be N1 minus 1 by N1 by N2 minus 1. Okay, now F2 value is given minus 10 centimeter. Okay, this is minus 10, and F1 value is given plus 10 centimeter divided by 10. N1 value is given 1.5 divided by 1.5 by N2 minus 1. Okay, so minus 10 by 10 is equals to minus 1. So now do the cross multiplication, you get 0.5 equals to 1.5 minus 1 is 0.5 equals to this minus 1 will be positive, 1 minus 1.5 by N2. Okay, now you take this negative on this side and this will go to the other side, so you get 1.5 by N2 equals to 1 minus 0.5, that is 0.5. Okay, so N2 will be 1.5 by 0.5, okay, that is 3. So the refractive index of the liquid must be equals to 3. This is a hypothetical liquid, there is no such liquid of refractive index 3. A hollow sphere and a solid sphere having the same mass and the same radii are rolled down through a inclined plane. The hollow sphere reaches the bottom first. The solid, so what is the condition? We have a hollow sphere, we have a solid sphere. We have a hollow sphere and a solid sphere, both are dropped from the same inclined plane. Okay, now when you are dropping it, okay, from the same inclined plane, the mass is same, so that means the force acting on this both sphere will be same. Force acting on them is same means because they have the same radius, okay, their torque acting on them will also be same. Okay, so torque on hollow sphere and the solid sphere, both cases will be same, because torque is basically force into this component, right, from the surface of the inclined plane. Now this component of force, that is this component of the force will be same, right, and this distance is same for the both the spheres. Now you have to find what is the moment of inertia of the individual cases. Moment of inertia for solid sphere is given by 2 by 5 mr square. And moment of inertia for hollow sphere is given by 3 by sorry 2 by 3, not 3 by 2 by 3 mr square. Okay, so this is the moment of inertia of hollow sphere. Now torque on both cases are same. So from here we say that I solid alpha solid must be equals to I hollow alpha hollow. Okay, so this is the condition, right? Torque means I alpha, force means ma. So force is mass into acceleration. Now what I told you, if you have followed my lectures, that in rotational motion moment of inertia plays the role of mass, so and angular acceleration is alpha, right? So torque plays the role of force. So force equals to ma in linear motion, torque equals to I alpha in rotational motion. Okay, so from here we see that alpha solid divided by alpha hollow equals to I hollow divided by I solid. That is, now mr square will cancel. You get this as 2 by 3 divided by 2 by 5. That is 5 by 3. Now this is greater than 1. Right, 5 by 3 is greater than 1. So from here we say that alpha s must be greater than alpha hollow. So angular acceleration of the solid sphere is much more compared to hollow sphere. So whoever has the higher acceleration, that object will reach the bottom with a higher speed, right? Because both of them are starting with same energy, they are starting with same torque. So whoever has the higher acceleration, that object will have the higher speed. So that means because its angular acceleration is more, solid will reach the bottom with greater speed. Okay, so the solid sphere reaches the bottom with greater speed. Option B is correct, right? Interesting question. Only thing you need to know is this concept and these concepts. Okay, now next question. A boat has a green light wavelength lambda equals to 500 nanometer on the mast. What is the wavelength would be measured and what color would be observed for this seen by a diver submerged in water by the side of the boat? Given NW is equal to 4 by 3. This is not related to Doppler effect. By the way, if you are thinking boat is static, so boat has green light of lambda is equal to 500 nanometer, and they ask you what color would be observed. Now color of a light does not change whenever from wherever you observe, because color is associated with frequency. So color of the green light will remain green, wavelength will change. Okay, so as it is, as you are observing from under the water, okay, the wavelength will change. How it will change? Based on the refractive index. So wavelength will be given by original wavelength divided by the refractive index. Okay, remember that wavelength is proportional to 1 by n. Wavelength is proportional to 1 by n. So 500 divided by 4 by 3, that is 500 by 4 into 3. So it will be 125, that will be 375 nanometer. So green and 375 nanometer is the answer. Okay, the color will not change no matter from where you are observing. Color is a property of frequency. Frequency is constant no matter where you go. Medium, it does not depend on medium. Only wavelength changes, speed changes, but frequency remains same. Refer to the figure. Assuming the internal resistance of the battery to be negligible, a voltmeter connected between the points A and B should read. So here we have a combination connection. Okay, and if you connect a voltmeter here, okay, what will be the reading? Easy question. So first we have to find the equivalent circuit. Here we have a 6 volt battery. I am just drawing one. we have a 1 ohm resistance. Now here we have 2 ohm and 2 ohm connected in parallel. So 2 ohm and 2 ohm connected in parallel. What is the equivalent resistance? Two equal resistances connected in parallel. The equivalent resistance is exactly half of them. That is 2 by 2. So 2 by 2 means it is obviously 1 ohm. So this is also 1. This is also 1. The voltmeter is connected like this. Now we have to find what is the current in the circuit. So what is the current? Total resistance is 1 plus 1, that is 2 ohm. So what is the current? Current will be 6 by 2, that is 3 ohm, 3 ampere. So what is the voltage drop across this? So current is 3 ampere. So voltage drop is 3 into 1, that is 3 volt. So the voltmeter will also record 3 volt, right? Option C is correct. Next question. A cycle followed by an engine made of 1 mole of ideal gas in a cylinder with a piston, okay, is shown in the figure. The heat exchanged by the engine with the surroundings at constant volume is. So what is the heat exchanged by the engine at the surrounding at constant volume? Now what is the meaning of that? So that means when the volume is constant. So if you see this diagram, PV diagram, volume is constant only when it is changing from here to here, right? Volume is only when it is moving from A to B. So only at this stage the volume is constant, and at this stage whatever is the heat exchange, that you have to calculate. So what is the formula for that? So volume constant means there is no work done by the gas. So work done is 0. That means dq must be equals to du. Why? dw is 0, volume is constant, pdv, dv is 0. So from here we know that du is given by NCV dt, right? NCV dt is the volume. Now 1 mole gas, so it will be simply CV dt, or it will be 3 by 2, CV value is given 3 by 2 r dt. Okay, now r is a constant, so I can write this equation as 3 by 2 d of rt. d of rt. Now what is rt? PV equals to nRT, right? Now n is 1 mole, so d of rt is basically nothing but d of PV, right? N is 1, that's why. Now volume is constant in this given case. So volume is constant means V into dP. So d of RT is nothing but V into dP. Just little bit of knowledge of differentiation can change, make or break it. Okay. So now here what you have to do, 3 by 2 V into dP. Now V is basically same for A and B, so you can write either A or B, does not matter. If you see in the options, in all options they have mentioned VA, so that's why I will also write VA. So as I said, volume is same for A and B, so you can write VA or VB, does not matter. So 3 by 2 VA dP. Now what is dP? dP is initial pressure minus final pressure, higher pressure minus lower pressure. Okay, higher pressure minus lower pressure, easier to remember. So higher pressure is at B, lower pressure is at A. Okay, because this is going in this direction, and as you can see, higher is this is lower. So PB minus PA. So this is the heat supplied to the system. This is the heat supplied to the system. So 3 by 2 PB minus PA into VA is the heat supplied. Okay, good question. Now next one. Figure shows x comma t, y comma t diagram of a particle moving in 2 dimensions. If the particle has mass of 500 gram, the force acting on the particle is. So here we have two graphs. Okay, one represents the displacement along x-axis, another one represents the displacement along the y-axis. Now if you see that this graph, the x graph, the slope of the graph is constant. slope of the graph, and each and every point is constant. That means along the x direction the velocity is constant. Okay, that means acceleration is 0. So if acceleration is 0, so what is the force acting on it? So force acting on it along the x direction must be 0. Force equals to ma, right? Now in this case, if you see, the slope is changing from each and every point. Okay, slope is changing each and every point. So here velocity is not constant. Velocity is not constant, so acceleration is not 0. Okay, now you have to find the average acceleration. But how to do that? So we will use the relation that S equals to ut plus half at square. Okay, this is the formula that we are going to use. Now initially the object was at origin, so from the origin means velocity at the beginning was 0, right? So here we will use y equals to half ay t square. Okay, so this is the formula that we are going to use. After 2 seconds, if you see, after 2 seconds t equals to 2, the displacement is given by 4 meter. Displacement is given by 4 meters. So 4 equals to half ay 2 square. Right? So we got ay equals to 2. Okay, you can cancel it and you will get ay equals to 2. So what is the force along y direction? Force along y direction, mass is 500 gram, that is 0.5 kilograms into 2, that is 1 Newton. So force is 1 Newton along y-axis. So 1 Newton along y-axis, option A is correct. Interesting question. Now next, for the circuit equivalent capacitance between P and Q. This kind of questions are very common. You can expect one of such questions coming in COMEDK. Now this is a particular question, maybe this exact question will not come, but this type of questions are very common. Now if you see that this point and this point are actually same. Similarly, this point and this point are also same. Right? So if this point and this point are same, so here we can say this resistor, this capacitor and this capacitor, they are all connected in parallel. Okay, because they all have one same starting point over here. Okay, so you can say this capacitor. Obviously the orientation will be changed here also, but orientation does not matter in case of capacitance series or parallel, right? So orientation, you have to be slightly imaginative to solve such questions. Okay, now, so this capacitor, so once I draw the equivalent circuit, everything will be easy, but before drawing the equivalent circuit, it is very, very difficult. Okay, so you have to understand that this point and this point are same. Okay, that means every resistor actually starting, this resistor is starting here, this resistor is starting here. Okay, this resistor is ending here, this resistor is ending here, and this one also is ending here. So they are all starting and ending points are same. That means they are in parallel combination. Okay, now if you see these two are easy to understand. Okay, these 2 points are same, so you just rotate it, you get these 2 capacitors are in parallel. This is easy. Okay, so these 2 capacitors are connected in parallel, and this one is alone, so this one is just a resistance capacitance in series. Now here we have C, 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 C. Now as we know, in case of parallel combination, capacitance gets added, so the capacitance is 3C, here the capacitance is 2C, and we have last one with C. Now you have to apply the equivalent law for series, that is 1 by C equivalent equals to 1 by 3C plus 1 by 2C plus 1 by C. That is 1 by 6C, 2 plus 3 plus 6. Right? So it will be 9 plus 2, that is 11 by 6C, or C equivalent equals to 6C by 11. 6C by 11. Correct answer is option D. Okay, now next question. A negatively charged oil drop is prevented from falling under gravity by applying a vertical electric field of 100 volt per meter. If the mass of the drop is 1.6 into 10 to the power of minus 3 grams, the number of electrons carried by the drop is. Very interesting question. So first we have to calculate the charge, then we will find the number of electrons. So what is the formula? Q into E is the force due to electric field, and that should be equals to the weight of the drop. Now if it has n number of electrons, then Q should be equals to NE, right? That is the quantization principle. It should be integer multiple of n, so n into E, right? So from here we say n into E into capital E equals to mg, or n is basically mg by E into E. Now mass mass of the drop is 1.6 into 10 to the power of minus 3. Gravitational acceleration takes 10. E is 1.6 into 10 to the power of minus 19, and electric field is given by 100 volt per meter. So 1010 cancels, obviously 1.6 cancels, and you get this as 10 to the power of 18 minus 3. Okay, minus 19 plus 10, 10 to the power of 8 minus 18. Minus 18 goes up, becomes plus 18. So plus 18 minus 3, so it will become 10 to the power of 15. So 10 to the power of 15 electrons are present in the drop. Next question. Three charges Q0, minus Q and minus Q are placed at the vertices of an isosceles right angle triangle as shown in the figure. The net electrostatic potential energy is 0 if Q0 is equals to. So here we have three charges, Q0, minus Q, and this is also minus Q. The lengths, this is a right angle isosceles triangle, so though both sides are L. So what is the length of this side? This will be L root 2, right? You can apply Pythagoras theorem, or you can remember it. This is like a square, okay, but half of the square is missing, so it is just like the diagonal of a square, which is A root 2, here L root 2, okay. These are the very standard formulas. Now you have to find what is the potential energy of the system. Potential energy of the system is given by K Q1 Q2 by R. Okay, so first let us find this one and then this one. All the potential energies gets added. Q0 minus Q by L, and lastly is these two. So that is plus K minus Q by L root 2. Remember, there is no square here. Okay, square is for electric field, electric potential, only one of them. Okay, no square. And the final electrostatic potential energy, this is the formula for electrostatic potential energy, and that value is given as 0. Okay, so now what we can say, this K will be common, L will be common. They will all go common, and they can all go to the other side, multiply with 0 and become 0. Okay, now we have to simplify this equation. So minus Q0 minus Q0 plus Q square by root 2 equals to 0. Okay, now minus Q0 minus Q0, that is minus 2Q0 plus Q square by root 2 equals to 0. Okay, now simplify this. So Q square by root 2 must be equals to 2Q0. Okay, this one I took other side, so one of the Q's is cancelled, so we get Q0 equals to Q by 2 root 2. Okay, now if you see the options, this option is not given. So what I have done wrong? Is it something incorrect? But carefully if you see the options, okay, there is one option which can be simplified further. Okay, so which one can be simplified further? this one. Why? Because root 32 means 16 into 2. That is, we can write this as 2q by 4 root 2. 16 into 2, 16 square root is 4 and 2 is obviously root 2. Now if you simplify this, you get this as q by 2 root 2. So what was our answer? So definitely this is the answer. So if you solve a question and finally if you see that your answer is not matching and if you are sure that your process is correct, then before rechecking your calculation, you check the options once more. If there is a possibility of simplifying one of the options, simplify that and see if they are matching with your answer or not. In case this is not happening, that means your calculation is wrong or your solution may be include some wrong assumptions. Okay, the potential gradient along the length of an uniform wire is 10 volt per meter. B and C are the 2 points at 30 centimeter and 60 centimeter on a meter scale along the wire. The potential difference between B and C will be. So here we have, a long wire. The potential gradient means if you move by 1 meter, if you move 1 meter distance, you will get the potential to be 10 volt. Okay, so per 1 meter the potential is 10 volt. That is the meaning of the potential gradient. Now you say that at 30 centimeter and at 60 centimeter, okay, you have 2 points A and B. So what is the voltage difference that you are trying to find? Also you can remember this way is that potential gradient does mean only one thing, electric field. Potential gradient is nothing but electric field, dV by dl. There is a negative sign, but who cares, we don't need the sign over here, right? We will need it only when it's required. So this is given as 10. Okay, now what is the distance, dl? This is dl. Okay, what is dl? dl is basically 60 minus 30, that is 30 centimeter, that is 0.3 meters. Okay, so the dl value is 0.3 meters. You have to calculate the potential difference, that is dv. So dv equals to 10 dl, that is 10 into 0.3, that is 3 volt. So the voltage difference is 3 volt. Okay, this is the voltage difference. A capacitor is charged through a potential difference of 200 volt. When 0.1 coulomb charge is stored in it, the amount of energy released by it when it is fully discharged. So obviously if it is discharging means whatever energy is stored when it is charging, the same amount of energy it will release when it is discharged. Okay, so this is also kind of a misleading question. You have to identify the underneath question. So charge is given, voltage is given, so what is the energy? Half CV square. Okay, and we know that half C into V is Q, so it will be Q into V. So this is the energy stored in the system while charging. It is half into 0.1 into 200, that is 100 into 0.1, that is 10 joules. Okay, so 10 joules is the energy stored, and that same amount of energy will be released when it is fully discharged. Okay, next question. The figure shows stopping potential Vs and frequency nu for two different metallic surfaces A and B. The work function A as compared to that of B. So here we have two graphs. Okay, A, this is cutoff frequency nu A, this is cutoff frequency nu B. Now from the graph we can see that nu B is greater than nu A, right? So cutoff frequency is more means the work function will also be more for B. Okay, so work function of A must be less than that of B. So work function must be less than that of B, because work function is nothing but H nu 0. Okay, so nu 0 is this one. This one is nu 0 for A, this is the nu 0 for B. So because the value of nu 0 for B is more, so it will have a higher threshold energy or work function. Another question, figure shows current in a part of an electric circuit, then current I is. So here we have a part of the circuit. Okay, so you have to find what is the current I. Okay, 2 ampere goes in, 2 ampere goes in. So from the Kirchhoff's current law, 4 ampere must be going in through this point. Now after reaching over here, 1 ampere goes out, and here 1.3 amperes goes out. So 1.3 and 2, 1 are going out. That means what is going out here? Total current that goes out is 2.3. So what is this current I? I must be equals to 4 minus 2.3, that is 1.7 ampere. So it is 1.7 ampere. Option A is correct. The EMF of a cell is epsilon and its internal resistance is R. Its terminals are connected to a resistance capital R. The potential difference between the terminals is 1.6 volt for R equals to 4 ohm and 1.8 for R is equal to 9 ohm. Right? So we know that what is current? Current is basically given by epsilon by R plus capital R. Right? And we also know that terminal voltage is basically given by epsilon minus IR. Okay, so from here we can calculate epsilon is basically I into R plus R. Let us put that value over here. We get I into R plus R minus R. Okay, I is common, right? So R cancels, and you get this as I is basically terminal potential divided by R. Okay, so what is I1? First case, I1 is voltage is 1.6 and resistance is 4, so it will be 0.4 ampere. I2 is given by 1.8 by 9, that is 0.2 ampere. Okay, now what we will do, we will use this equation once more, and we can calculate whatever is the value of epsilon and whatever is the value of R. So first we will calculate V1 equals to what? 1.6, and that is equals to epsilon minus I1 is 0.4 small r, and 1.8 equals to epsilon minus 0.2 into R. Okay, this formula we are using for two different currents. Okay, epsilon and R value are same. Now let me rewrite this in the bottom, epsilon minus 0.4 R. So now we just need to subtract, minus plus cancels, we get 0.2 equals to 0.4 minus 0.2 is 0.2, that is into R. So from here we get R equals to 1 ohm. Okay, if you get R is equal to 1 ohm, you put that in this equation. So 1.6 equals to epsilon minus 0.4, that is epsilon equals to 2 volt. Okay, so epsilon is 2 volt, R is 1 ohm. Correct answer option B. Okay, do not try to guess the answer by randomly choosing the values. That will be very long. Okay, rather you can skip this question if you are not confident, or use the step-by-step process to solve it. Okay, an electric heating element consumes 500 watt when connected to a 100 volt line. If the line voltage becomes 150 volt, the power consumed will be. So electric heating element, basically that means it has a fixed resistance. Okay, and we know that power is given by V square by R, right? Voltage is given, so power is V square by R. So power here 500 watt, initially power was 500 watt and V square was given 100, so 100 square by R. So R is 100 into 100 divided by 500, so 0 0 cancels, you get 20. So the resistance is nothing but a tiny 20 ohm. So if the resistance is 20 ohm, now voltage you have increased it to 150 volt. Power consumed, new power consumed will be 150 square divided by 20, right? So it will be 150 square, so 150 into 150 divided by 20, so it will be this one, so and 75, right? 75 into 15, which is 750 plus 120, not 125, 375. So 750 plus 375, so it will be 1125. Okay, so how can I do it? This multiplication, you can use the in-house calculator available to you, or while multiplying with 15, what you can do, divide this into 10 plus 5. So first multiply with 10, you get 750, and then multiply with 5, you get 375. Okay, and then you add this. This is the trick while solving quickly. Now, next. A circuit is as shown in the figure, then the current from A to B is. So here we have a circuit diagram, and they ask you to find the current from A to B. So current in this branch. Okay, and here we have two batteries like this and like this. So first what we have to do, we have to say this current is I1. Okay, current through this is I, and this current will be I1 minus I. Okay, this is going in this direction, right? So I1 minus I, this will also give you I1 minus I, and after they meet here, it will give you I1. Okay, simple calculation. You can simply apply Kirchhoff's voltage law to calculate it. There is one more shortcut method, but at this point of time, I don't want to teach you that. So I1 into 10 I1 plus, in the direction of current, that is 10I, equals to, the battery is also sending in this direction, so 10. So I1 plus I equals to 1. So I1 plus I equals to 1. This is the first equation. Now next, now we are moving into this side. Now this side, battery is sending current in this direction, and we assume that the current in the this junction is going in this direction, right? It is going out, right? That's why it is minus here. Now current in this loop is going in this direction, so you have to take this as negative. So minus 10I plus 15 I1 minus I equals to 5. Now here also the battery is sending current in the direction that we have chosen, so that's why the right hand side is positive. So minus 10I plus 15I1 minus 15I equals to 5, or 15I1 minus 25I equals to 5. Now you can divide every term with 5, so you get 3I1 minus 5I equals to 1. Okay, now only thing is left, you need to eliminate this I1. So how to do that? Multiply this with 3 and then subtract it from this equation, right? So from there we get 3I1 minus 5I equals to 1, and multiplying 3 we get 3I1 plus 3I equals to 3. Now just do the subtraction. Okay, you get this cancels, and you get minus 8I equals to minus 2, or I equals to 1 by 4. Okay, so I is equal to 1 by 4, that is 1 by 4 ampere, or 1000 by 4 milliampere, or 250 milliampere. It is positive, so correct answer is 250 milliampere. Okay, so minus minus cancels, even though the initially it was negative, negative sign cancels, so we got it as 250 milliampere. The ratio of de Broglie wavelength of proton and alpha particle which have been accelerated through the same potential difference. So if you accelerate a proton and an alpha particle through same potential difference, say V, okay, they will acquire some amount of energy, kinetic energy. So what is the kinetic energy of the proton? Kinetic energy of the proton will be charge of the proton into the potential difference, right? What will be the kinetic energy of the alpha particle? Alpha particle has doubly positive helium, so that means 2e into V. Okay, so alpha particle has 2eV and proton has eV. Now why I am talking about kinetic energy when they have asked you about de Broglie wavelength? Because we know that de Broglie wavelength can be calculated as h by p or equals to h by square root of 2m E. E is the kinetic energy, right? P and E is related through this formula. So lambda proton will be equals to h by 2 into mass of the proton into its energy. Energy is E into V. Okay, and lambda of alpha particle will be h divided by mass of the alpha particle. Now alpha particle has 2 protons and 2 neutrons, so its mass is basically equivalent to 4 of the mp into 2eV. Now they ask you to find the ratio, right? So you have to divide this. So if you divide this, obviously common terms will be cancelled. Lambda p by lambda alpha. So now this will go up, so this will go up also, this h cancels, mp cancels, e cancels, not 2, e cancels and vv cancels. Okay, vv cancels, so this one goes up, so we get on the top 2 into 4 into 2 divided by root 2. This 2 is still there, so this 2 will also cancel, so we get this as 2 root 2. Okay, square root of 4 is 2 and 1 extra 2 is here, so 2 root 2 is the answer. So option C is the correct answer. Next question. The relative permeability of medium is 0.075. What is its magnetic susceptibility? So relative permeability mu r is 1 plus susceptibility. So susceptibility is mu r minus 1, that is 0.075 minus 1, that is 0.925, and there is a negative sign also. If a galvanometer current is 10 milliampere, the resistance of the galvanometer is 40 ohm and shunt is 2 ohm is connected to the galvanometer to convert it to a ammeter. The maximum current which can be measured by this ammeter. So here we have a galvanometer. Okay, the resistance of the galvanometer is given by 40 ohm. And we have a shunt of 2 ohm. Okay, now the maximum current through the galvanometer is given by 10 milliampere. Okay, so what is the maximum current it can measure? Maximum current is the current in the circuit. So remaining current will pass through this 2 ohm, so I minus Ig. Right, now we know that because these two are connected in parallel, so the voltage across the galvanometer should be equals to the voltage across the shunt, that is 40 into Ig should be equals to I minus Ig into S, that is 2. Okay, so this cancels, we get 20, so 20 Ig equals to I minus Ig, or I is equals to 21 Ig, or 21 into 10 milliampere, that is 210 milliampere. Okay, 210 milliampere, or it can be written as 0.21 ampere divided by 1000, not by 100. Okay, so 0.21 ampere is the answer, not 2.1. Don't fall for the trap. Okay, next question. A magnet of length 0.1 meter and pole strength 10 to the power of minus 4 ampere meter is kept in a magnetic field of 30 Weber per meter square at an angle of 30 degrees. The couple acting on this is, so couple is given by MB sin theta. Okay, so now here M is not given, pole strength is given. So magnetic moment for a magnet is given by the pole strength into the distance between the poles. Okay, now distance between the poles directly is given 0.1 and pole strength is given 10 to the power of minus 4. 10 to the power of minus 4 into 0.1, that is 10 to the power of minus 5. This is the magnetic moment of the magnet. So you have to put those values, 10 to the power of minus 5. B is given 30 Weber per meter square, so 30, and sin theta is given sin 30, sin 30 is half. Okay, just put the values and try to calculate it. So here we get this as, so you can see 10 and this will cancel, so 3 by 2 into 10 to the power of minus 4. So why I achieved this? Because it is given in 10 to the power of minus 4 format. So you get this as 1.5 into 10 to the power of minus 4. So correct answer is option B. Next question. To produce a magnetic field of pi Tesla at the center of circular loop of diameter 1 meter, the current flowing through the loop is. So magnetic field at the center of a current carrying loop is given by mu naught by 2 I by d. Right? Now they told you that not d, sorry, let me write it, R. They told you the diameter 1 meter, right? So diameter 1 meter means mu naught by 2 I by d by 2. Okay, d is the diameter, or you get this 2 cancels, you get this as mu naught I by d. D is the diameter over here. Okay, now let's put the value. So magnetic field that we require is pi Tesla. So pi equals to, what is the value of mu naught? 4 pi into 10 to the power of minus 7. I we are trying to find, and diameter is 1 meter. So I will be equals to pi divided by 4 pi into 10 to the power of minus 7. Pi cancels, 10 to the power of 7 by 4. Okay, 10 to the power of 7 by 4. So you can write this as 10 into 10 to the power of 6 by 4, that is 2.5 into 10 to the power of 6. So correct answer option C. Okay, just check the options once before deciding which way to go. Okay, now next question. Two wires of same length are shaped into a square and a circle. If they carry same current, the ratio of magnetic moment. Okay, we have one circular coil, one square coil. They all are carrying the same current. So what is the magnetic moment? Magnetic moment is NIA, National Investigative Agency. N is the number of turns. Now here we have only one turn, so N does not matter. So magnetic field of the loop. Okay, so magnetic field of the loop is I into area. So suppose the length of the wire is L. If the radius is small r, then 2 pi r equals to L, or from here we say r equals to L by 2 pi. Okay, now what is the area? Area is pi r square, that is I into pi into L by 2 pi whole square. L by 2 pi whole square. Okay, this is the magnetic moment of the loop. Now what is the magnetic moment of the square? Again AI into area. Now what is the area? Here it is, area is length into breadth. Now in all the sides have same length, right? So that length will be L by 4, right? You have total length was L, you shaped it into a square, so each side will have L by 4 as their length. So it will be L by 4 whole square, right? That is IL square by 16. And from here just simplify it a little bit, it will be IL square pi by 4 pi square. So one of the pi will cancel, so it will be IL square by 4 pi. Now they asked you square first, circle second. So the ratio, when you are trying to find the ratio, square will be first divided by loop, that will be equals to IL square by 16 divided by IL square by 4 pi, or 4 pi by 16, so it will be pi by 4, or pi is to 4. So correct answer option C. Two long conductors separated by a distance d carry current I1 and I2 in same direction. They exert a force F on each other. So we have two long wires carrying current I1 and I2, and force here means force per unit length. Force per unit length, that is basically given by mu naught by 2 pi I1 I2 by d. This is the formula, the force between two parallel current carrying wires. Okay, I1 I2 by d. Right, now the current in one of them is increased to 2 times and its direction is reversed. The distance also increased to 3d, the new value of the force. Now if both are carrying current in the same direction, they will attract each other. If the current is in the reverse direction, they will repel each other. But the magnitude of the force does not depend on the direction, it only the attraction or repulsion depends on the direction. So formula will not change based on the current is flowing in the same direction or opposite direction. Okay, so F dash, new F dash equals to mu naught by 2 pi. So one of the current is doubled, say 2 I1 is doubled. Okay, so I1 is 2 I1, I2, and the distance is now 3d. So we can say it will be 2 by 3 F. Okay, so it will be 2 by 3 F. Two long thin wires ABC and DEF are arranged as shown in the figure. They carry currents I, the magnitude of the magnetic field at O. So again another interesting question. Now here we have a current carrying wire which carries a current I in downward direction. Here we have a current carrying wire which is carrying current I in the upward direction. So we have to find the magnetic field at this point O. Okay, now this is a half wire, and this portion of the wire you can cancel because they are going in the same direction as the point. So whatever magnetic field due to this, that will be cancelled due to this one. Okay, so you can simply consider these two are opposing each other, so they will not have any effect in this case. So only these wires are important. Okay, now this is a half wire. Half wire, why I am saying? Because to calculate the magnetic field we have the formula for a long infinite wire. So if this is a long wire, the other long half you have to consider this is on the other half. Similarly here also you have to consider this is the other half. So whatever is the magnetic field due to this long wire, out of that it will be half of that. Okay, so what is the formula for long wire? It is 1 by 4 pi mu naught by 4 pi, sorry, mu naught by 4 mu naught by, sorry, the current due to a long infinite wire is given by mu naught by 2 pi I by R. okay, ideal sin theta by r, but for a long infinite wire that goes, so you get this is the formula for long infinitely current carrying wire. Okay, so here this distance is a, this distance is also a. So if you see that magnetic field at O is outward, magnetic field at O due to this current is also outward. So both currents are magnetic field outward. So that means here the magnetic field is will be added. Okay, if there one is outward, another one is also inward, then they will cancel. Right, here magnetic field due to this is outward, magnetic field to this is also outward. Both of the current is giving you outward current, and this is the magnetic field due to a very long current carrying wire. So that is here you have only half of the long wire. So the total magnetic field due to any one of them will be this. And we have two of them having the same current and having the same direction, so you have to just consider them, multiply them, so you will get this as the formula for this. So you can say that actually it is nothing but only one single current carrying wire, and you are finding some magnetic field somewhere here. Okay, slightly tricky to understand, but if you have studied this kind of questions, this might be easy for you. So mu naught by 4 pi 2 pi, okay, I by E. This is the answer, mu naught I by 2 pi A. Next question, the moment of magnet is, the volume is given and moment of magnet is given. What is the intensity of magnetism? So intensity of magnetism is defined by magnetization per unit volume. Okay, moment, magnetic moment per unit volume. So intensity is magnetic moment per unit volume. Okay, so magnetic moment is 1.2 and volume is 15 centimeter, that is 15 into 10 to the power of minus 2 into 2 centimeter is minus 2, and 1 centimeter again 1 into 10 to the power of minus 2. So it will be 1.2 divided by 15 into 2 into 10 to the power of 6. Minus 2, minus 2, minus 2, minus 6 goes up, becomes plus 6. Okay, so it becomes 12 by 30 into 10 to the power of 6. 1 0 can be cancelled over here and we get 4. So 4 into 10 to the power of 5. This is the value. There is one small mistake I made here. There is a decimal over here. Okay, so that decimal I missed. So 1.2 was here, so it will be 0.4. So 0.4 means it will be 0.4 into 10 to the power of 5 or 4 into 10 to the power of 4. This decimal I missed. Okay, so correct answer will be this one. Now next question. Nucleus of an atom whose atomic mass is 24 consists of. So nucleus of an atom having 24 mass number. Okay, so it consists of 11 electrons. Nucleus does not have any electrons, so any options having electrons is incorrect. They are asking about your about nucleus, not about the atom. Okay, so electrons are not part of the nucleus, so nucleus you can delete, electrons you can delete. So 11 protons, 13 neutrons, or 11 protons and 13 electrons. Again, electrons are not part of the nucleus, so correct answer is 11 protons and 13 neutrons. Also remember that number of neutrons should be less than equals to number of protons. Okay, number of protons can never be less than number of number of protons can never be greater than that of number of protons. Okay, what I am saying, number of protons can never be greater than number of neutrons. Neutrons will always be higher or equal. Okay, neutrons will always be higher or equal. If in a nucleus number of protons becomes higher, the nuclear is completely unstable and it will break down very quickly, and there may be some energy release as well. Okay, Tritium consists of, tritium is basically an isotope of hydrogen which consists 1 proton and 2 neutrons. So 1 proton and 2 neutrons, correct answer option A. A uniform electric field E equals to 2 into 10 to the power of 3 Newton per Coulomb is acting along the positive x-axis. The flux of this field through a square of 10 centimeter on a side whose plane is parallel to the YZ plane is. So here we have an electric field in this and we have a YZ plane. What is the electric flux? Very easy question. Electric flux is basically given by E dot dA, but here they are same direction. So sin theta is 0, cos theta is 1, sin theta is 0 anyway, so it will be just E into A. So electric field is 2 into 10 to the power of 3, and what is area? Area is given by square of 10 centimeter. Square of 10 centimeter means 10 into 10 into 10 to the power of minus 4. Okay, because it is centimeter square, so 10 to the power of minus 4. So that is 2 into 10 to the power of 3 into 10 to the power of minus 2. This is 10 to the power of minus 2, so it will be 20. Okay, so 20 Newton per Coulomb meter square. So this is the answer. Okay, option A is the answer for this question. According to classical theory of the circular path of an electron in a Rutherford atomic model. So according to the classical theory, the Rutherford atomic path will be a spiral, because the electron will no longer be stable in a circular path, it will fall towards the nucleus. So it will be a spiral path, not circular. Circular is Bohr's theory, Rutherford's theory. According to classical theory, it should be a spiral, not a circle. As one considers orbit with higher values of n in hydrogen atom, the electric potential energy of the atom. So increases, decreases, remains same, does not increase. So electric potential energy is basically given by minus 2 into 13.6 by n square. So if you increase number of if you increase the n, the magnitude of U decreases. Okay, but because it's a negative value, the negativity decreases, that means it is increasing. So potential energy is actually increasing. So potential energy increases with the increase in the number of n. Which of the following statement is true for hydrogen atom? Angular momentum is proportional to 1 by m, linear momentum is proportional to 1 by m, radius is proportional to 1 by m, energy is proportional to 1 by m. Energy is proportional to 1 by n square, radius is proportional to n square. Okay, linear momentum, let's see, angular momentum is given by nh by 2 pi. So it is proportional to n, so does not proportional to 1 by n. And if you check, linear momentum will be proportional to 1 by n. From this only we can say mvrn, right? Mvrn is the angular momentum, right? So mv is the linear momentum, that is given by nh by 2 pi rn. So what is Rn? Rn proportional to n square. So nh by 2 pi n square, n cancels. So linear momentum is proportional to 1 by n. Okay, so correct answer is option B. Easy question, but not super common type of question. Doubly ionized helium atom and hydrogen ions are accelerated from rest through the same potential difference. The ratio of final velocities of helium and hydrogen is. Okay, so they are accelerated, so that means they have once they are accelerated, what is the energy of hydrogen? Energy of helium, we already solved one similar question, but that was a different de Broglie wavelength question. So the energy of the helium is 2 MeV. Okay, what is the meaning of that? This is half into 4 mass of proton into V square. Okay, from here we say that V square equals to 4 eV by 4 MP or eV by MP. This is for helium, velocity of helium. Now energy of hydrogen will be E into V only, that is equals to half mass of proton into V of hydrogen square. So velocity of hydrogen square equals to 2 eV by MP. Okay, so they ask you what is the ratio of their final velocities. First is helium, second is hydrogen. So V He by V of hydrogen, both square. Okay, so we are just dividing them. So it will be eV by MP divided by 2 eV by MP. So eV by MP cancels, you get half. So V He by VH is 1 by root 2. So it will be 1 is to root 2, not root 2 is to 1. Okay, so whenever you are solving ratio related question, be careful and solve it carefully. What is the conductivity of semiconductor in ohm per meter if electron density is given by 5 into 10 to the power of 11 centimeter cube and hole density is given by 8 into 10 to the power 13 centimeter cube. Mu is given by this and mu h is given by this. Okay, so what is the conductivity? Conductivity is given by, for a semiconductor, is defined by E into number density of electron into its mobility plus number density of holes into its mobility. Okay, so this is the mu Ne, right? That is the conductivity, mu Ne. Now E is 1.6 into 10 to the power of minus 19. Number density is given by number density of electron is given by 5 into 10 to the power of 12 and mobility of electron is 2.3 plus hole density is given by 8 into 10 to the power of 13 and mobility of hole is given by 0.01. Okay, now let's simplify this. 1.6 into 10 to the power of minus 19. 5 into 2.3 is 10, 11.5 into 10 to the power of 12 plus here it will be 0.8 into 10 to the power of 12. So what I am trying to do, I am keeping the 10 to the power value same so that it can be common and come out of the addition. So 1.6 into 10 to the power of minus 19 into 10 to the power of 12, 11.5 plus 0.8 which is 12.3. Now please don't ask me how I got this. Okay, that is basic math. So from here we get this as one more thing, I made one mistake here. It is given in centimeter cube. Everything was given in centimeter cube division. That means in meter cube it will be, per meter cube it will be both will be plus 6. Okay, so it will be 10 to the power of 18. This will be 10 to the power of 19 and after I multiplied as I have done, it will be 10 to the power of 18 over here and 19 over here. So it will be 10 to the power of 18. Okay, so now you have to calculate this as 12.3 into 1.6, that will be approximately 1.5 9 into 1.5 12 into 0.6, that is 1.7 or 17 into 10 to the power of minus 1, that is 1.7. So it will be approximately 1.7. So you can see the correct answer will be 1.968. Okay. If you use the calculator and exact values, you will get much better answer than whatever I have done mine. I have approximated it. Next question, if c is the velocity of light, which of the following is correct? So velocity of light is given c. So this will be given by 1 by square root of mu naught epsilon naught, and from here we get mu naught epsilon naught equals to c square. Okay. A potential barrier of 0.3 volt exists across a PN junction. If the depletion region is 1 micrometer wide, what is the intensity of the field in this region? So potential barrier 0.3 volt is given, the width of the depletion region is given. So we know that electric field is depletion region voltage divided by the width of the depletion region, that is V by D. So V is 0.3 by 1 micrometer. Micrometer means 10 to the power of minus 6. So that is 3 into 10 to the power of 5 volt. Okay, so it is 3 into 10 to the power of 5 volt per meter, that is volt per meter, right? So this is the answer. A circular coil of radius 0.1 meter has 80 turns of wire. If the magnetic field through the coil increases from 0 to 2 Tesla in 0.4 second and the coil is connected to a 11 ohm resistor, what is the current in ampere flow through the resistor during the 0.4 second? So here we have the magnetic field through the coil changes from 0 to 2 Tesla in 0.4 second. Okay, so here we see that change in magnetic field dB is given by dB by dt is given by 2 minus 0 by 0.4. So it will be 20 by 4, that is 5. Okay, so dB by dt we have calculated. Now we have to calculate what is epsilon is basically given by n a dB by dt, right? A into B is 5, so if you do differentiation, A comes out. Number of turns is given by 80 and radius is given by 0.1. So from here we say that area is pi r square, that is pi into 0.1 whole square, that is 22 by 7 into 0.1 whole square, 0.01. So from here we get this as 80 into 22 by 7 into 0.01 into dB by dt is 5. Okay, so from here we calculate the epsilon. Now this is not over yet. The resistance is given 11 ohm, so you have to calculate the current as well. So current is basically the epsilon divided by resistance. So everything 80 into 22 by 7 into 0.01 into 5 by 11. So here we got 2. So from here we get this as 5 into 2, which is 10, 10 into 0.1 is 0.1, 0.1 into 80 is 8, so it will be 8 by 7. Okay, so answer is 8 by 7 ampere. Now next question. In an LCR circuit, the voltage across the resonance, capacitance and inductance is 100 volt each. If the capacitance and inductance is 10 volt each, if the capacitance is short circuited, the voltage across the inductance. So here it is given that XL equals to XC equals to R. Not XL equals to XC equals to R, sorry. VL equals to VC equals to VR equals to 10 volts. So every one of them has the same voltage. Now total voltage applied is also 10 volt, right? Total voltage applied is also 10 volt. Now you might say, sir, the resistance value is not given over here, so how you saying that VR is also same? Because capacitance and inductance has 10 volt. So capacitance is 10 volt, inductance is 10 volt, right? Applied voltage is 10 volt. Now that means this condition, this is a resonance condition. Okay, if this is in resonance condition, if the circuit is in resonance condition, that means whatever is the applied voltage, the same voltage should be across the resistance as well. Now if all of the component have the same resistance, same voltage drop across them, then their resistances must be equal. In this case, the reactance must be equal. So XL must be equals to XC, and obviously that is the condition of resonance. Now because these voltages are all same, so this will also be equals to R. So this is the first thing that you have to realize from this question. Even though the question might appear a little bit complicated, but this is the first condition that you have to identify. Now you have to apply the second condition when the capacitance is short circuited. So capacitance short circuited means XC now is equals to 0. Okay, now you have to find the voltage across the inductance. Voltage across the inductance means, first of all, you have to obviously find the impedance of the circuit. Impedance of the circuit will be R square plus XL square. XC is 0. Now XL equals to R, so you can put this as R square plus R square, that is R root 2. Okay, so this is the value of the impedance. Now you have to find the current. What is the current in the circuit? Current in the circuit is applied voltage divided by impedance. Applied voltage is 10 volt and impedance is R by root 2. Right? Now what is the voltage across L now? Voltage across L will be the impedance into current. Now impedance is reactance, inductive reactance value we have already established. This is equals to R, so R into 10 by root 2R, so R cancels, so it is 10 by root 2. So the voltage across the inductance is 10 by root 2, that is option C. Next question. If N is the number of turns in a coil of fixed length, the value of self-inductance varies as. So self-inductance is basically proportional to N square by L. Okay, so normally it is proportional to a number of turns, but if you fix the length, okay, if you increase the number of turns, the length will also, it is proportional to number of length also. So if you change the length, if you fix the length and if you change the N, okay, then the corresponding relation becomes N square by L. I have done this one of the lectures in the past, if you have watched that, so it is directly proportional to N square. In an AC circuit, the resonance is equal to the resistance. The reactance is equal to the resistance. The power factor of the circuit will be. So what is the reactance? Reactance is basically XL minus XC combined together is called the reactance, and it is equals to the resistance. Okay, now they asked you what is the power factor. Now in a AC circuit, this is obviously not in resonance. Reactance, okay, I misspelled it. Now tan theta, that is the phase, is given by reactance by resistance. Okay, XL minus XC is reactance, this is this one. Now this, both of them are equal, so tan phi is 1. So tan phi 1 means phi is equals to pi by 4. Now phi is pi by 4. Now what is power factor? Power factor is cos phi. So cos phi is cos pi by 4, that is 1 by root 2. So the power factor is 1 by root 2. Okay, be careful, don't answer it as 0. Now I have reached the end of this lecture today, and if you have liked this, don't forget to give it a like and comment and share it with your friends. I'll be back with more such videos in future, and all the best for your upcoming COMEDK exam.